Trillions of deadly gas bubbles were trapped beneath the Arctic Ocean. The ice melted. Hell just woke up. Beneath the Arctic Ocean, right now, are frozen bubbles of gas locked inside ice, trillions of them, sitting there, stable, for thousands of years. The ice is melting. You woke up this morning, made coffee, checked your phone. Maybe you complained about the heat. Maybe you didn't notice it at all. Either way, while you were doing that, sensors on the floor of the East Siberian Arctic Shelf recorded methane concentrations rising at rates that didn't exist in the baseline data from 10 years ago. You didn't feel it. You won't. Not yet. Most climate conversations focus on carbon dioxide, emissions targets, glacier retreat, sea level projections measured in centimeters per decade. Important, real, but slow enough that policy and adaptation can theoretically keep pace. Methane doesn't work that way. Methane is 80 times more potent as a greenhouse gas than carbon dioxide over a 20-year period. And on the floor of the Arctic Ocean, locked inside crystalline structures called methane clathrates, there is more carbon stored than in all of Earth's coal, oil, and natural gas reserves combined. All of it combined. In 2023, a joint research team from Stockholm University and the University of Alaska published findings from the East Siberian Arctic Shelf. Their instruments detected methane plumes rising from the seafloor at rates measurably higher than baseline data from a decade prior. Not a marginal statistical fluctuation, a documented, reproducible acceleration. In 1999, geologist James Kennett proposed the Clathrate Gun hypothesis. His argument, under the right temperature conditions, seafloor methane deposits don't release slowly, they release suddenly, a massive, self-reinforcing pulse of greenhouse gas that warms the atmosphere, which destabilizes more clathrates, which releases more methane. A gun with a hair trigger. And the temperature of the water above that trigger is rising every single year. If you've never heard the words Clathrate Gun before, that's not an accident. By part 3, you'll understand why this specific scenario keeps certain climate scientists awake at night, and why it should keep you awake too. Subscribe to the Doomsday Archive and turn on notifications. Every week we cover the predictions science confirms are real. This one may be the most personal of all. So what exactly is methane clathrate? Picture a cage made of water molecules, frozen, rigid. Locked inside that cage under high pressure and low temperature, a single molecule of methane gas. Perfectly stable, perfectly contained. Now, raise the temperature by 2 degrees. The cage doesn't weaken gradually. At a certain threshold, the crystalline structure collapses, the methane releases rapidly. Scientists call clathrates fire ice, because if you hold a piece of Arctic seafloor clathrate and strike a match, it burns. Solid ice on fire. The East Siberian Arctic Shelf alone holds an estimated 500 to 1,000 gigatons of carbon in clathrate form. Humanity has released approximately 650 gigatons from all fossil fuel burning since the Industrial Revolution, total over 150 years. The ESAS could match that in a geological instant. But here's what they're not telling you. The debate among scientists isn't whether Arctic methane is increasing. The instruments confirm it is. The debate is about rate, whether the release will stay gradual enough to manage or whether tipping points exist that, once crossed, accelerate beyond any human response. In 2021, a landmark study published in Science concluded that Arctic permafrost thaw is already releasing more carbon than Arctic ecosystems absorb. The Arctic, historically a carbon sink, has flipped. It is now a net carbon source. That transition was not projected to happen until mid-century. It happened in 2021, 30 years ahead of schedule. Think about what that means for you personally. The models that governments use to plan infrastructure, agriculture, water supply, and coastal defense, those models are built on projections that are already 30 years behind reality. The seawall protecting the city where your parents live, the reservoir supplying your region's drinking water, the agricultural zone producing the wheat in your bread, all of them planned around a timeline that the Arctic has already invalidated. You didn't choose this, but you are living inside it. In Part 3, we go further. A historical event from 56 million years ago tells us exactly what a large-scale methane release does to a planet, what it did to the species living on it, and why the rate of what's happening now is 10 times faster than that event. "56 million years ago, the planet experienced the Paleocene-Eocene thermal maximum, the PETM. Global temperatures rose 5 to 8 degrees Celsius. Deep oceans acidified. Between 30 and 50% of deep-sea species went extinct. It took over 100,000 years to restabilize. The leading hypothesis for the trigger? A massive seafloor methane release, almost certainly clathrate-driven. The PETM carbon release is estimated at 2,000 to 5,000 gigatons over 20,000 years. Current human emissions are releasing carbon 10 times faster than that. Now bring it out of the geological record and into your kitchen. You're a farmer in southern Spain. It's 2041. You've been farming the same land your grandfather farmed, but the precipitation pattern that defined this region for centuries has shifted northward. Your growing season is 6 weeks shorter than it was in 2010. The aquifer your irrigation depends on is 30% depleted. Last year, you lost 40% of your wheat crop to a heat event that the regional forecast didn't predict because the satellite providing that forecast data was degraded. You're not a statistic. You're a person who can no longer feed your family from land that fed 3 generations before you. Now move north. You're in Munich. It's the same year. Your city's drinking water comes from alpine snowmelt, but the snowpack that historically released water gradually through spring and summer now melts in a concentrated 6-week window. The infrastructure wasn't built for that timing. In dry summers, your region faces water rationing for the first time in recorded history. You're not in a developing nation. You're in one of the wealthiest cities in Europe. Move further. You're in Dhaka, Bangladesh, population 23 million, sitting less than 10 meters above sea level. By 2041, under median IPCC projections, before methane amplification, your city experiences tidal flooding 150 days per year. The monsoon season delivers 40% more rainfall in a shorter window, overwhelming drainage systems designed for a different climate. You don't have the option of moving. You have nowhere to go. FEMA and European climate agencies project that by 2050, climate-driven displacement could affect over 200 million people globally. That's not a projection about the distant future. The children who will be those displaced people are alive right now. But here's what they're not telling you. All of these projections, the farms, the aquifers, the flood maps, are built on models that do not fully incorporate large-scale clathrate feedback. They represent the floor of what's possible, not the ceiling. In Part 4, we talk about the responses, what's actually being attempted, and one proposed solution that could make all of this dramatically worse if it fails. So what's being done? More than most people realize, less than the scale requires. The most direct response to Arctic methane acceleration is aggressive emissions reduction. Slow the warming, stabilize ocean temperatures, keep the clathrates frozen. The Paris Agreement targets exist precisely to stay below the thresholds associated with large-scale clathrate destabilization. Current national commitments, if fully implemented, which they haven't been, place us on a path toward 2.5 to 3 degrees of warming by 2100. The threshold associated with significant clathrate response in scientific modeling sits between 1.5 and 2 degrees. We are currently at 1.2 and accelerating. So geoengineering has entered the conversation, seriously, at the governmental level. Stratospheric aerosol injection, the deliberate release of reflective particles into the upper atmosphere to reduce incoming solar radiation, is now being actively researched by Harvard, Oxford, and national science agencies. Conceptually, it works. Major volcanic eruptions demonstrated. When Mount Pinatubo erupted in 1991, it temporarily cooled the planet by half a degree. Here's what they're not telling you. Stratospheric aerosol injection doesn't remove methane from the atmosphere. It masks the warming while concentrations continue to build. And if the program is ever interrupted by geopolitical conflict, funding collapse, or technical failure, the suppressed warming returns rapidly in what researchers call termination shock. Picture this. You're living in 2055. A stratospheric aerosol program has been running for 15 years, quietly keeping global temperatures stable. Then a major geopolitical conflict disrupts the international coalition managing it. The program stops. Within a decade, the warming that was chemically suppressed for 15 years accelerates back, not gradually, in a compressed surge. Agricultural systems, water infrastructure, coastal defenses, all calibrated to a stable temperature regime that no longer exists, fail simultaneously. The people most affected are not the ones who made the decision to start the program. They are the ones living in coastal Bangladesh, in sub-Saharan Africa, in river delta cities across Southeast Asia, the ones with the least resources to adapt. If this is making you uncomfortable, it should. Hit the like button. It helps this channel reach the researchers and policymakers who need to hear this conversation. Share it with someone who thinks climate change is a slow, distant problem. In Part 5, we arrive at the number, the timeline, and a 2024 data point that the scientific community is still processing because it doesn't fit the models anyone was using. So what are the actual odds? This is where the science becomes genuinely uncomfortable. Unlike a fault rupture or an orbital collision, large-scale clathrate destabilization doesn't come with a clean probability percentage. The system is too complex. The tipping points are not precisely mapped. What scientists can say is this: we are inside the temperature range where destabilization becomes possible. We are accelerating toward the range where it becomes likely, and the mechanisms that would slow that acceleration are all operating below the speed the physics requires. In September 2024, Arctic sea surface temperatures in the Barents and Kara seas hit anomalies more than 4 degrees above the historical average for that month. 4 degrees, in a system where 2 degrees is the modeled threshold for significant clathrate response. The instruments are not malfunctioning. The data is real. Now make it personal one final time. You have a child who is 8 years old today. By the time that child is 30, they will be navigating a world shaped by decisions made and not made in the next 15 years. The food they can afford, the city they can live in, the summers they can survive without air conditioning that 3 billion people on Earth currently cannot access. Their future is not abstract. It is being written right now in policy rooms and corporate boardrooms and research labs by people who are mostly not thinking about your 8-year-old. James Kennett called it a gun. The metaphor is precise, not because catastrophe is inevitable, but because at a certain point, the process stops waiting for human decisions. It proceeds on its own timeline, according to physics that do not negotiate. The window to influence that timeline is still open, but windows close. Subscribe to the Doomsday Archive so you're here for what comes next, because next week we're covering a threat that doesn't come from the sky, the ocean, or the atmosphere. It comes from a single point of failure buried inside the infrastructure that 4 billion people depend on every day. A system that has never been stress-tested against the scenario we're about to describe. You use it every morning. You used it today. This is the Doomsday Archive. Tomorrow is coming. Will you be ready?